Thank you, man. Thank you. Yeah, I got overwhelmed about the introduction of myself. Hello, all. Uh, as I'm the former student of our institution, I don't have much introduction about myself as Margaret ma'am has already provided. So, uh, so let's get into the topic. Are you able to see my screen? Hello.
Yes.
Thanks. So today we are going to discuss about the emerging technology in the field of electrical. So basically, today technology, so many new innovations are getting evolved in the electrical field, such as in EV, and in place of renewable energy, we are moving towards some geothermal and some new technologies also. And moreover, more astonishingly, in today's world, AI is blooming so drastically and so so fastly it's evolving than any other field. So in place of AI is get integrated with our electrical field also. So that's what I put it here. AI powered management, which is in future in every field AI integrate with the AI tool. So then the next topic is the smart grids. Previously, we don't we have some other we have grid, but in not in smart grid. Smart grid in the sense uh, it's all related to power electronics and full of power automation tools. So in place of smart grid, we can easily restore the power supply back, and we can balance the load. We can see the real time monitoring, and we can check the current, yeah, electricity flow. It means that the data flow, it is a two-way of communication. Like it uh, like data can be analyzed, and and another part is we can flow the it can flow the electricity. So we can integrate the smart grid with the renewable energy sources. As as new technology is moving towards renewable energy sources, so it must be integrated with the smart grid. So as I mentioned earlier, right? So it supports load balancing and site management. If for example, if in any of the places there is surplus amount of energy, energy is there, means we can pull the surplus amount of energy to the deficient area energy using smart grid. That is called as load balancing. We can manage most of the power outage and we can improve the reliability of the e- electricity flow using smart grid. And the next topic is about renewable energy system. As many of them know about the renewable energy system such as solar panel, hydroelectricity, windmill, tidal, geothermal, like those are all called renewable energy resources. So it is a replaceable of non-renewable energy sources as the non-renewable energy sources are decaying. I mean, it's decreasing a vast. So we need to move into another way of uh, producing the power. So we are moving towards a renewable energy system, and in most of the world countries, they are uh, taking initiative. I mean, they are promoting to produce renewable energy sources using EV. In most of the houses, we can see many of them install solar panels. So it is a one way of renewable energy sources, and it produces lower carbon emission compared to non-renewable energy sources. And it's sustainable and natural. So move on to this next topic is the energy storage system. The energy storage system is like we can take a phone. We have a storage system called battery in our phone. That is energy storage system. And if we drive a bike, EV bike means there is a battery. That is an energy storage system. Like this, there are more energy storage system in a shorter way. But when comes to the I mean consumer product consumer area means we need massive energy storage system that is using batteries, which is lithium ion or sodium ion or solid state or supercapacitor. Currently we are using lithium ion. It's blooming now. We in, in Kashmir part we have found a vast amount of lithium ion source. So using that we can store large amount of energy in the lithium ion lithium. And another source is supercapacitor, which is kind of energy storage, but it, it is used in industrial purpose areas for instant pickup. If some energy outage is going means we need instant startup. So in that place we can use supercapacitor to power on the whole factory or whole surrounding areas. So it usually supports renewable energy resources like solar and wind. We can install this energy storage system in the area of solar and wind energy place where we can use it as a backup during the outage. And one more highlight point is it reduces the stress on the grid because most of the time we can't rely on the most of the time we can't rely on the grid. So this this basically depends on the uh, renewable source energy or non-renewable source energy, which has to be produced. It cannot be produced instantly. So The alternate way we can produce a power using this energy storage system instantly. Next is EV and its charging infrastructure. Today, the current world trend is moving towards EV and the charging infrastructure for the EVs, e-vehicles. In most of the people nowadays using e-bikes and e-cars, and the government is promoting the use of e-vehicle to reduce the carbon emission. Sorry. So EV is two types. One is battery vehicles, and another one is hybrid e vehicles. Both used to reduce the carbon emission and to promote the healthier life. I mean, to give me a moment. Sorry, I got call from my office. Uh, Currently, we are looking on the TV, what right? So the government is promoting e-vehicles to reduce the carbon emission. It's of two type. One is using AC, and another one is DC. I mean, it's related to charging types. So charging type is of three types. One is level one and level two and fast charging. So level one is like slow fast charging, which is capable up to 120 volt supply, and the level two is of normal use, which support 220 volt, 240 volt, and is more or like fast charging, but not up to the mark. And the other one is fast charging, which is of DC type. Wireless charging, it's in blooming stage. I mean, it's in testing phase. In future, we can expect wireless charging. So currently, we are using grid to charge our vehicle, which is a time-consuming process. In future, they are planning to install some wireless charging on the road, which is of we are using wireless mobile charger, right? When we place our phone on wireless device, it will get automatically charged. So they are trying to implement in that way in some part of Sweden, I guess. I'm not sure where it is being tested, but it is of Western Europe, I guess. So they are testing it for wireless charging. And another technology is booming is vehicle to grid technology. Uh, Now it's like one way of charging, which is from grid to vehicle. In future, if some vehicle is in halt stage or it's not in use stage, means we can use the battery. I mean, use the battery power to charge a grid when there is any power outage. So they are planning. I mean, they are planning to use this technology in future. The other one is wide bandgap semiconductors. So semiconductors, in the sense, it's not a full type of conductor. Semi, in the sense, it should reach a threshold value, then only it can start conducting. So wide gap, in the sense, so most of the elements will have some less band gap, which we call it as EV. Uh, this conductor which has wide band gap, in the sense, uh, 2 EV, 2 electrovolt, we will say. So it can withstand high temperature and high voltage and high frequency. So for this, we are using silicon carbide and gallium nitride. Silicon carbide is the second strongest element next to diamond, and most widely they are using in power electronics and in some part of mechanical in mechanical parts like braking system. They are using this silicon carbide because of this enormous tensile strength. And the next one is gallium nitride. This one is high cost compared to silicon carbide, and it's used in some part of medical use. And it is efficient and it's smaller and lighter when compared to other semiconductors. As I said earlier, right, it is used in a power electronic device. So it is implemented in EV chargers, inverters, and fast switching circuits. Overall, it reduces the energy losses and improve the overall system efficiency. And the next technology is HVDC. Currently, we are uh, producing the electricity or power in the form of AC. The major drawback of AC transmission is the loss while transmission. So to overcome this, they are using HVDC, which reduces the losses and it can transfer at high rate without any loss. So the point mentioned here is reduce power losses over long distance. So basically, the power is generated in the form of AC and then it's converted into DC using inverter. I mean the converter, and it's boosted to high voltage using booster and then it transmitted over long distance. And at the receiving end, the same process has to be occurred, which converts the DC into AC, and it's supplied to the local customer using distributed transformer. The main advantage of this is reducing the power loss over long distance. This can be applicable in the area of remote regions where the grid and the power generation area is far away. Means we can implement this technology over there. Like if in some parts of Tamil Nadu, they are producing wind energy, right? From there, the grid will be much far. So to avoid the losses, they usually convert the AC the energy into DC and they transmit over the transmission, and then it's converted back to AC and distributed to the local areas. And it helps to stabilize the power flow between the region. And the next one is wireless power transfer. As I gave an example of a wireless mobile phone, right? So there, this is that one relates to wireless power transfer. Now we are using small the devices such as Bluetooth, mobile phones, even some batteries also is there. So in future, uh, we can export wireless power to reduce the to reduce the laying of wire. And this uses the magnetic field to energize the devices. For example, you can say if there will be one tower in one area which is used as a sender with high maximum frequency using that, and from there will be a receiving net which is a O to receive those energy. I mean the magnetic
இது
field
ஓடிட்டு
from there.
இருக்கட்டும். நீங்களே எண்டு கொடுத்துருங்க இந்த இது கடைசியா முடியும் போது.
It produces produces the magnetic field at a higher rate. From there, the receiver end will be home. So we receive this magnetic field using a receiver, and we can charge up our devices. For example, we can say Tesla coil. The technology was invented back before World War II by Tesla, but somehow it got dropped. They are not using that, but again they are trying to reusing the technology, and it's of testing phase. These points are all assumption that using the electrical charging station like that. So it's often testing stage. And then it's microgrid and distributed energy. This microgrid in the sense, it's like if you take an institution, means we have some battery power source. I mean backup power source like a generator, or we install some solar panels over buildings to power up a few building blocks or few households, like few households. This is called from microgrid. We don't depend totally on the power distribution center. So we can use this microgrid to charge. I mean to power up our local needs using this. So it's of we can depend on whether it's of wind energy or solar energy or backup energy which we discussed earlier. It's energy storage system, right? Using that we can implement in microgrid also. So it improves energy reliability and it reduces shortage. So as I said earlier, right? If there is any outage from the main distributor, we can use this as a backup. Not backup. We minimize the dependency on the main power grid using this microgrid. And using this microgrid, we can provide our power to the main power grid also. It is of two-way communication, like it's of selling part. And the next one is smart transformers and solid state transformers. So this technology is used because the setup cost of transformer is too high, it will be around 35 lakh to 40 lakh per transformer. To replace the transformer where the cost of transformer is too high. So to avoid any malfunction or to avoid any overload cost, we can use smart transformer. Smart transformer in the sense we can install sensors, power electronics to, to calculate the load amount and to identify what to identify whether is there any fault over there or is there any malfunction will happen means what to to prevent the uh, burst of the transformer or to reduce the transformer loss we use power electronics. And solid state in the sense previously that transformer size is of huge. So uh, to reduce the transformer size, we use smart transformers, which is power electronics, to reduce the transformer size. Now you can see right that transformer size has become too small when compared to 4 to 5 years back. It was huge. Now it's reduced. The size has reduced almost 30 to 40% using this smart transformer. As I mentioned earlier, the communication between a grid and user. So it mostly it's a two-way communication. We can check the health status of the transformer using this power electronics. And uh, in transformer, we use coolers, which is of liquid. To check the status of the cooler, we use power electronics. And to check the health status using the power electronics. And the next one is advanced production and automation system. In every house, there will be a stabilizer or voltage stabilizer to protect the device if there is any high voltage fluctuation or low low power means that stabilizer will protect the device from damage. So like that, there will be a protection for the power grid also. So for that, they use intelligent electronic device for real-time monitoring. As you know, right, the electricity board will produce a huge amount of power in terms of megawatt and gigawatt. So if any malfunction occur means it will cost it will cost life. So to avoid that, they have installed some controller and health monitoring unit to check the status of it and to check the status and response of using this electronic device. Nowadays, the technology has improved a lot, and the error has been minimized much more. And one more highlight point is it reduces the power outage and downtime. The next one is Internet of Things. Many of them are smartphones, which, which is connected to the external world using internet. So the same is applicable to the electrical field also, in terms of monitoring, in terms of health checking, in terms of energy storage, and in terms of uh, to maintain the cost, how to reduce the electricity bill use. We can implement those things in using IoT, which is called as IoT. In recent time, we are seeing uh, fan in the form of internet, which will get automatically turned on when we enter the room, or the light when we enter the room means the light get automatically turned on, and the fan will automatically turn on. And if you move away from the place means or from the room means the light will go off automatically and the fan will turn off automatically. It's all by means of Internet of Things. So we can integrate electrical and the integrate electrical and internet for our convenience. This can be achieved by using some devices and chips. We, we can use some kind of devices called uh, sensors, controllers, smart meters. This can be directly integrated with our main line. In terms of electricity board means we can directly integrate with the energy grid. And it controls most of the loads and power system using this technology. As I said earlier, right, we can monitor and manage the power using manage control, advanced system. So we can implement the same in IoT to reduce the peak loads and peak demands. This can improve the energy efficiency in most of the area like home, industry, and commercial buildings. And the final topic is artificial intelligence in power systems. At the starting of the session, I mentioned that AI is blooming and it can be integrated with our electrical field. So the AI is used in IT field, like in the form of machine learning, and yeah, AI can be integrated with electrical field in the area of power grid to minimize the error output. So, to minimize the human intervention. Human intervention or human mistakes can be overcome using this AI. So real-time fault detection and diagnosis can be achieved using this AI tool. AI. And plays a key role in the field like smart grids or in load balancing or energy saving. This can be achieved using AI also. This, yeah, that's all. Uh, is there any question so that I can answer up? No, thank
The link for this is posted in the chat box. Kindly join the link. Students, kindly join the link which is posted in the chat box. Till now, 8 participants joined. Request everyone to join the quiz. Only 9 participants have joined. Kindly join so that we can start the quiz. you. 11 participants have joined. Participants, kindly join the link. It is posted in the chat box. Wait for 2 more minutes to start the quiz, requesting all the participants to join the quiz. Kind request for the participant to join the quiz, which is posted in the chat box. Waiting for the other participants to join. Those who have not joined, kindly join. So kindly value the time of others. Ma'am, Margaret, ma'am, shall we start? Okay. So the participants who are all joined, kindly answer the questions. You will be given a question with the options. So you need to select the correct option, and finally your score will be displayed at the end of the quiz. Okay. So I'm going to start the quiz now. Cheer up for Priya, who is leading the scoreboard. The leaderboard is topped by Priya again, followed by Mohan Raj. Yeah, Mohan Raj has come to the top. So there is competition. Mohan Raj and Priya, they are leading the first place. So the new topper has come, Adarsh. Competition is between Mohan Raj, Adarsh, and Priya. So there is a close call between Mohan Raj and Priya. Now the competition is between Mohan Raj and Adarsh. Oh, we got a new topper on the board. He is Mr. Diva. We have 4 more minutes to close the list. Now we have got a new topper on board, Monica. 2 more minutes to go to end up the quiz. As of now, the leaderboard is topped by Monica, followed by Prithvivasan and Jiva. It's time for us to close the quiz. So here, the winner of the quiz is Miss R. Monica, followed by Jiva, and then the third place goes to Cornelo Jonathan. So these are the top scorers of this quiz. Thank you, participants, for attending the quiz. Thank you. Congratulations for the winners. Yes, ma'am. Yes, ma'am. Ma'am, I am unable to share the screen. With my mobile, I am unable to share the screen. I shared the screenshot of the winner in the chat box.
Thank you, ma'am.
Thank you. Thank you, ma'am.